In the previous video, we coded our spawner that allows to generate infinite obstacles. They move towards us to try to destroy the player, and the player's goal is to dodge these obstacles to increase his score. I told you that the loop was done, but we need to add a little bit of visual effects to our game to make it more snackable. Another word you can find on the internet is juicy. To create a juicy game is to create a game that gives the player lots of feedback and lots of visual effects. For that, I'll start by going to the asset store and look for something like SnackableFX, and I will search only free assets. No, results are not useful. I'll try to look for cartoon particles instead. Here is something that can tempt me. It's cartoon FX free. Those are visual effects, and we can use them in our game to create some interesting things. There's a lot of stuff that could be cool in there as visual effects. So look for cartoon FX free. When you're logged in, you'll click on Add to my assets, and once you've done that, you can access it in Unity. So we'll go into Unity, Window, Package Manager. Here we said Cartoon FX. Cartoon FX free. We can import the package. So the package is very light. It's 2.5 mega, which is pretty light. I'll click on import to import the package. I'll deselect everything that I'm not interested in. I'll keep the prefab, all these two, but I'll delete all the demo stuff because I don't need it. Matter I'll keep, mesh I'll keep, script as well, and everything else. No, I'll delete also the easy editor. That's for creating our particle system manually. And delete this too. Okay, we're good now. I click on import. We wait for the import and we'll test if it works, just to check if I didn't forget to import a necessary dependency. Okay, we have GMO assets, cartoon FX. I'll take this package here and drag it into packages to stay organized. I delete the GMO assets folder. And then in packages, I have the shader simpleton and cartoon FX. We have now different prefab. We have something with electricity. We have explosion, boom. Fireworks. There's kind of contact effects. And magic light effects. There are really a lot of visual effects in this package. A tornado here. Virus. So there's a lot to choose from, and we can start selecting effects that could go in our game. The debris could go, for example. What else? So like the smiley, adding a smiley to say that we managed to avoid an obstacle could be nice. And smiley are very popular in hyper-casual games right now, so let's use it. Over here, skeleton. Skeleton could be nice when you die. I'll check a bit more what we have, because I don't remember this package. Skeletons again. Bad cloud. That could be cool for Halloween. We have a broken heart too. That could be used when you lose a hit point. Okay, sorry, I got a bit lost discovering those visual effects, but you saw them with me, and now I reckon we've got plenty to do. So let's start with the smiley appearing above the player. This can be tricky, so we're actually going to take the smiley, where it is, I just need to find it here. We'll take the smiley and put it inside the player here. We'll position in 0, 0, 0 in relation to the player, then we'll click on restart. This will replay the smiley, and you can see that we don't see it. Whereas if it was on top, we would see it about here. Here in 1.5, let's try to keep round values. Now the smiley is in a good position. So for now, I just looked for a position where we could see our effect. Now I zoom in on it with F, I go to GameObject create empty, which create an empty object at the point where I want to instantiate the smiley. So, and I rename it, and I'll call it, what do we like call it? Let's keep it simple, just pause for position. I'll put it inside the player, and I'll remove the pickup smiley. So, every time a cube touches the obstacle behind it, we've earned a point for our score, and we're going to pop up a smiley. Now, if ever an obstacle comes in contact with the player, at that moment we will display the skeleton particle system. Okay, here we go, let's code this. I go back to the obstacle script because it's the most appropriate script to do what we have to do. In this obstacle script, I'll create two variables, public GameObject win particles and lose particles. So the particles when we win, the particles when we lose, and I also create a public transform win particles pose, which corresponds to the position where we want to instantiate the win particles. So at the moment I collide with the player, I'll write an instantiate in order to instantiate the variable lose particle, and I'll instantiate it at collision.GameObject.transform.position. Instantiate will allow me to generate an object, and I say I want to create it at collision.GameObject.transform.position, which is the position of the player when the obstacle touches it. So we'll instantiate the particles at the player's position, and this third parameter, if you remember, quaternion.identity. Here for now, we'll instantiate the particles, we'll destroy the player, but immediately it will make a scene manager load scene, so it will reload the level instantly, which is not good now because we won't have time to see the visual effects. So what I'll do is create a public void reload level function. I create a specific function that will reload the level, and instead of, sorry, I just copy, cut and paste, and instead of calling this piece of code directly, I'll do an invoke that's going to allow me to invoke my function here, and I'll invoke it after 3 seconds, for example. I'll leave a 3-second delay so the player can enjoy the visual effects, and only then we'll reload the level. I'll do the same thing underneath. I'll do an instantiate as I touch the out cube, except this time I'll instantiate the win particles here. So instead of instantiating loose particles, I'll instantiate win particles, and I want to do it to win particle pose, which is already a transform, so I don't need to do all that. I just set win particles pose dot position, which is just the position of the transform. Control S, and we should be good. Go back to Unity, wait for it to compile. Now, we need to do a little more settings. Our obstacle now has several new variables, as you can see. We will have to fill in these new variables. We said wind particles was going to be the smiley. Loose particles, we said, which one? No, not that one. I have to find it again. Yeah, that one could do. So I reselect my obstacle, and I'll put the particle system here. And for the wind particles position, which is a transform, I will fill it in dynamically like we did with the text. So we'll just rename the pose wind particles objects, just to make sure it's a unique name. I go back to the obstacle script, and in the start function here, I'll say that wind particle pose is equal to GameObject.find. I look for the object that has the name pose wind particles. Dot transform, because I want to get its transform. So this variable will not be filled in dynamically. We let it compile and we launch the game, and then we'll do some tests. First, I'll avoid the obstacle and check if I have the smiley appearing above my head. We're good. Now I lose on purpose. Boom, we explode, 1, 2, 3, and then the lever reloads. So our script worked well. I don't know if you had time to notice. If you didn't, you can go back in the video like 10 or 20 seconds. But by the time the player has disappeared, other obstacles have been generated. That's because we didn't handle the case where we need to stop the spawner. We could stop it when the player is destroyed. But for now, I won't bother making something too complex, because what we're doing here is not a real game, it's just a template and some tests. But we had an error in the console. When a new obstacle was generated after the player had disappeared, I was told the script was trying to access the player, but the player didn't exist anymore. Of course, if you try to access the wind particles when the wind particles doesn't exist anymore, because the player has been destroyed, you'll get an error in the console. So it's not a blocking error and the game still works, but you can always wrap that up in a try catch. You do try, which will say, well, try to do this. Then you do a catch, meaning pick up the error. You can actually write catch exception E to be able to catch an error message. Here I use exception when exception does not exist. We would have to write a using here, but when we have errors in Visual Studio, we can simply hover over the error, go to the little light bulb here, suggestion. I'm told that if I import system exception or using system, it should fix it. I'll select using system, and it added the using system automatically for me. And now exception is known. And then you can just do a print e.message. So now the exception, the error will be handled. Writing a try-catch block just allows you to say, try this, but it may crash. It's a piece of code that can crash, I know that, so I wrap it with a try. And if it crashes, you do this. Having an exception handled allows you to have a robust program that doesn't crash, because even if your code crashes, you had planned ahead that it might crash, and you had planned an alternative behavior instead of letting your game totally stop working. Okay, that's it for this little teaching on how to make your code more robust. We'll go back to Unity, and on my games I like to have movement, like leaves falling, flower petals flying, magical things spinning here and there. So I'll have a look at the particles again. Nice, I have, for example, a wandering spirit particle system to get little spirits while wandering around. Position it here, and position it well on the screen so that it's nicely visible. I just want to have something visual, you know, something moving on our scene. See, now here we have little spirits flying around. Can maybe even bring it closer to the camera a little bit. Just allow us to have movement in the game, and I like to have a little bit of movement to keep the player awake. Speaking of movement, we can also add a trail renderer to the obstacle. To do this, we'll add a component to our obstacle. I select it, add component, and I look for trail renderer. The trail renderer is the little light trail behind it. In terms of size, I say that we'll have a size of 0.8, for example, and that the size will decrease over time. For the duration of the luminous effect, I want it to be 1 second, so it will self-destruct after 1 second. And for the material, we'll create one. So we have no material. I go to the materials folder, I right-click, create material, and call trail. I go back to the obstacle, and I place the material I've just created here. And then we'll edit this material. We'll say it's a transparent type material, for example. As the obstacles are red, I'll put a red color, but I'll make it transparent by playing with the alpha property. That's it. Control S, I'll run the game to just check how it looks like now. Should be a bit nicer. Here, you can see the light trail behind it if it's not very visible. Yeah, there's one other thing that bothers me is that the cube have a weird behavior after it destroys the player. So when we destroy the player, we'll also destroy the cube at the same time, so we won't have the bug anymore. Okay, first, you've seen that the light trail works, but we can make it a little bit more visible. To do this, I'll continue to play with the property of the transparency of the model, and I'll make it a little less transparent, even if that's just a detail. And I show you one last trick to make the game even better. We'll go to Window, Package Manager, and I'll search for iTwin. I've already gone to the asset store and I've already added iTwin to my assets. That's why I'm finding it. If you never added iTwin to your assets, you won't find it in the package manager. You go to assetstore.unity.com, get iTwin, and once you have iTwin, you'll have access to it in the package manager. We'll click on download to download it. You see it's only a few kilos. Weight here, 74 kilos. I click import to import the package. I won't import the examples nor the README, and I won't import the images. I just import iTwin. Click on import to just import this one script. We'll click ignore. iTwin has been imported into plugins. Pixel placement, iTwin. I'll move it back into plugins. I won't put it in packages because plugins is also there's a folder in Unity, which is a bit special, in which we put, well, plugins, and I leave iTwin there. That's it. We don't need to touch this script anymore. And now I'll show you. I'll go back to the obstacle script. We had created our text here. So what I'm going to do now is I'll make a public game object text. I'll comment this so that you can have it on hand to get it back if you want. And I'll get the game object directly. So instead of saying that text is equal to all of this, now text is a game object. I say that text is equal to GameObject.find score text directly. Now, instead of having a variable of type text mesh, we have a variable of type GameObject. I'll copy the get component text mesh pro UGUI because when I try to change the text here, it doesn't work. because the game object doesn't have any text properties, it doesn't exist. It's Text Mesh Pro that has a text property. But now text has become a game object, so I have to do text dot get component dot text mesh pro UGUI dot text, and this will work. But before going further, we'll test the changes we did on our game to check if we didn't break anything. Sorry. We'll just restart the game, and I'll avoid an obstacle, and I'll see if my score is still incrementing, because it's where we did some modifications. And there my score is incremented, so we're good. Yep. And you see that if you look at the console here, object reference not set to an instant of an object, that's because we handled our error with the try catch. So, okay, so what we've done for now is replaced the Text Mesh Pro with the game object, which will allow us to use iTwin. iTwin is a plugin that's pretty well known. It's a really nice plugin and very easy to use. You have the documentation online, you just search for iTwin documentation, or you go on the website of pixelplacement.com/iTwin/documentation, Pixel Placement being the creator of the plugin. And here you have the list of the iTwin script functions. Not sure how many there are, maybe 50. Those are ready-to-use functions for you. And the documentation is well done. We will look at punch scale, for example. The documentation shows you everything you can do with iTwin. As a script allows you to create little animations, some funny visual effects, which is ideal when you want to make a snackable game. We have move to, which allows you to move an object to a position in a transition, punch position, punch rotation, punch scale to create visual effects on the position, rotation, and the scale. It will allow you to transform those in a funny and animated way. So there's a lot of stuff, and as I said, we'll choose punch scale. I click on it, and it takes me directly to the documentation. There, I can see how this function is used. It can be used like this, taking 3 parameters: the game object, the amount of size change, and the animation time. That's it. Or it can be written like this with the game object, which is the target on which we want to create the animation, and a hash table. A hash table is an array with key value. It can be infinite. You can have as many key values as you like. If you look here, these are all the possible parameters for this function. So this function is able to act on all these parameters. By default, we just need a vector 3 and a time, but if you need more precision and you need to work with very specific parameters, then you take the second possibility by creating a hash table, and then you use each parameter one by one, like time, 5, delay, 2, loop type, etc. It can become a bit more complex, but for now we'll just use the basic function punch scale. So when the obstacle collides with out, we increment our score. And what I want is to create an animation on the score. I would like to have a funny animation. So I use iTwin's punch scale function, but this is just what I copied from the documentation. It will be an iTwin. Visual Studio doesn't recognize iTwin, probably because I imported the script without leaving Visual Studio. I'm just going to reopen Visual Studio so it will take into account the different scripts I imported. Here you see now that iTwin was found. So I'll do an iTwin.punch scale. The game object I want to act on is text, because now text is a game object. Otherwise I couldn't have done this. Here I pass a vector 3, new vector 3, and I'll put 2, 2, 2, which means that I modify the size by 2 of the object. Punch scale will make it look like we're punching the object, and when we punch it, it will make the object grow very quickly, as if it had been compressed. Then we remove the punch, and the object will act as if it was a little elastic. It will make boing, boing until it finds its initial size. This is what this function does. This is the maximum size that I want my object to get, and the third parameter is time. If you look here, time, how long I want to create this animation. For example, 10.f, so that it lasts 1 second. Okay, let's go back into Unity to check it. I launch the game, and then you look at the score at the top. When the score increments, we should have an animation if I did it right, and if not, we'll fix it. And there you see it working. Look, it's great, isn't it? I reckon the effect is really nice, and it makes the game more snackable. Sorry. We can go even further. We can also use this punch scale on our player. The moment we collide with the player, so here, instead of doing a player destroy, instead of destroying the player instantly, we'll do a player destroy, 1, which means destroy him after 1 second. And just before that, we'll do an iTwin punch scale on the player. I won't put 2, I'll put 1.5, for example. I reckon it will be more than enough. It's going to create a funny visual effect on the player. Let's test this. Now you can create dozens of visual effects with iTwin, and it will make a game much prettier visually. So let's have a look. I'll zoom in a bit. Up, watch out. Boing. Here we added a quite funny effect. We'll do it a second time so that we can see it well. Okay, wait for it. Yeah, nice effect. It's nice, but maybe a little too slow. I will destroy the object after 0.5f, which will make it a little more dynamic, because I find it a little slow. Wow, that's just a personal opinion. You'll set it as you like. I'm just showing you how to use functions, and then you can do what you want. Okay, wait for it again. Yeah, not bad. Well, that's about how you can make your game more juicy, more snackable with iTwin. And I stop here for this video, and actually we finished our template. Now we have a template that we can reuse for our future games. We have imported everything we need, the cartoons shaders, iTwin, colors, we have canvas, we have the essential to get started. So before we move on to the development of our real project, in the next video I'll show you how to test this prototype on your phone directly. That will be the final video for the creation of the template, then we'll move on to the real project.